I hope I'm audible, right?
Yes, sir.
Yes.
Yes, Ashok sir, are you there, sir?
Yeah, a very good evening, sir.
Yeah, good evening, sir. So let's begin the session. Let me introduce you. First of
Sure,
all,
sir.
yeah. Thank you so much, sir. So hello, everyone. Welcome to the ATAL FDP hosted at RK University, Rajkot, Gujarat. This is the day 2 of the online session. And we are going through the cybersecurity and digital forensics. Today we are having a renowned personality from the Amrita Vishwa Vidyapeetham, Coimbatore, Professor Ashok Kumar Mohan. He is an assistant professor in the TIFAC core in cybersecurity. He is a certified hacker, certified ethical hacker. He is cybercrime investigation officer. He is having a good practices in the IT security and its audit. He is a consultant of the IT security audit, and he is the cyber forensics expert. He joined with the different law agencies. He is working with the police services, and he is solving some cyber crimes also. He is having a good expertise for the forensics, and he involved with the different startups also. So I welcome you, Professor Ashok Kumar Mohan, sir, and over to you, sir.
Yeah,
I'm going to stop my sharing. You can share your things, sir.
sure, sir. Thank you, sir. Thank you, sir. Thanks a lot.
Thank you, sir.
Yeah. A very good evening to everyone. So, as I introduced, I'm Ashok Kumar Mohan. So, I'm from Amrita University, down south in Tamil Nadu, Coimbatore. So, let me share my screen for a while. Sir, I hope I need permissions for screen share.
Yes. I'm going to do the same, sir. Wait,
Yes,
sir.
sir. Thank you, sir.
Yeah. Yes, sir. You are co-host now.
Thank you, sir. Thanks a lot.
Yes, sir.
Yes. I hope my screen should be visible, sir. You're able to see my screen, sir?
Yes, sir. Your screen is visible, sir.
Okay, sir. Fine, sir. Okay, sir. Okay, sir.
Please
so
go
very
ahead.
good evening, everyone. Just a minute. Yes. So I hope this is an faculty development program for pool of faculties, maybe researchers. A small portion of students also should be available. So before we start with, I just want to know some bits and pieces. I hope the chat should be open. Like, so what's individual's idea on digital forensics? Like, being an academician, I hope I'm an academician, most hailed academician for the past 5-7 years. And as I introduced, I used to support law enforcement. I used to be in cyber forensics. I used to be in different crime related investigation. And you name any certifications like ethical hacking, penetration testing. That's a part of my curriculum. So when we talk about digital forensics, right? This is my general template session, which I used to give for the general public. So drafting your first open source digital forensics course. So we have chosen this topic specifically for the crowd, those who are available here, mostly faculties and researchers. So with respect to government's initiatives, Indian government have also taken lots of initiative in supporting academicians like us, law enforcement, to make India a bit of secure in the digital era. So you and me, after a few years, maybe shortly from now, we'll be just drafting new courses. You say BTech, MTech, BSc, MSc, quite a good number of curriculums on digital forensics, cyber forensics, cybersecurity, and on. So I made the agenda simple. We'll have an introduction, some keywords, steps in digital forensics, and then we'll see something on the tools and techniques and what next. What next will be, I hope at the end of this session, everyone will be able to just draft your own course on cyber forensics. I'll also give my benchmark. I'll share you the presentation. I'll also share you the sample syllabus I have just formulated. So in any future, if you want any support in and around cybersecurity and specifically on cyber forensics, you can very well bounce back to me. So with this introduction, I'll just start with our session. Drafting your first open source digital forensic course. Why I have mentioned it as open source? Because like when we talk about digital forensics, it's all about commercial proprietary tools. So solving, maybe typically solving a case, unlocking a mobile, recovering a deleted file, working on some ransomware related cases, on any number of cases, mostly commercial tools are involved, highly paid tools. But being an academician and researchers, we'll be teaching students, we'll be framing syllabus, we'll be setting up an R&D lab, we'll be setting up center of excellence. All things will be revolving in and around open source digital forensics. Even after this course, you go to your management and say, hey, sir, I have got a session on digital forensics, quite interesting. We'll set up a lab in our university or college. The first recommendation from your management will be, sounds good. We'll just start with something publicly available or free tools or open source tools. So when we talk about these things to academic crowd, I used to stick on to the open source digital forensic word because we are going to discuss all about publicly available tools. I'll be talking in hand with free and paid tools. So introduction, you can see here a couple of things, something on the left-hand side of the screen and something on the right-hand side of the screen, right? Sir, is the chat box open for all?
Yes, sir. It's open, sir.
Okay, because when I try to put the chat box, okay, now it is everyone in the meeting. Sounds good.
Yes.
Thank you.
Yes, sir. Yes.
So participants can give me some chat replies saying that what you see on the screen. Left something 0010101, right something, some words, keywords, right? So what is your inference from this? So generally when we teach students, we teach them, right? Left-hand side is equal to right-hand side. If I give you a hint saying that this left-hand side is going to be the right-hand side, equivalent. So what is your concern or what is your opinion on this? Participants can type in the chat box, whatever you feel. I've also, for your ease of use and understanding, I have given you some color codes also. Okay, let me brief it. See, whichever I put on the chat box, this binary equivalent is equal to the tilde symbol. That's what I've given the yellow color code. The same way, whichever is on white is going to be equivalent to white, and whichever is on the black is going to be equivalent to black. So generally, when we talk about cyber forensics, for beginners, their key term will be all around recovery. Someone have taken a photo, they have hidden it, they have put a password, they have locked it, they have deleted it, right? So that's a general term. But cyber forensic in advance is something on a different dimension in the current day. But being a beginner, we have an idea saying that, okay, cyber forensics is all about searching for evidences. Evidence can be a photo, audio, video from your mobile, laptop, desktop, cloud, anything, right? So generally, when we talk this LHS into the RHS or proving something on the left-hand side, zeros and ones, binaries, the so-called computer language, proving something on the right-hand side, your ANSI, the human readable format, is the basic and the beginner level challenge on any cyber forensic equivalent. Fine. So who am I? As Sir gave already an intro about me. I am Ashok Kumar Mohan. So I'm the course instructor. Other than teaching at the university, I'm the course instructor for EC Council, CompTIA, Cisco, Mile2, most commonly available cyber forensic or cybersecurity related courses. And this is a center I hail from a center called TIFAC Core in Cybersecurity and R&D Research Center from Amrita Vishwavidyapeetham University down south in Coimbatore. And we are offering bachelor's and master's courses in cybersecurity. So I'm just teaching cyber forensics there at the university. And today's schedule, whatever we have planned for today's agenda is typically going to be in and around this. The 1 hour or 1 hour 30 minutes slot, which you are going to see, is going to be something in and around this. What is digital forensic? Because at the end of the day or end of a week, you go out and say, I have an FDP on digital forensic. Someone will ask you, okay, what's your understanding on digital forensic? What you understood? Give me a definition, just like we question students, right? 2 mark, write a 2 mark on digital forensic, write a 6 mark or 8 mark on features of forensic or steps in investigation, right? So we'll start with the basics. What is digital forensics? That is the learning part. Second thing, when you go out and claim saying that we know something on forensics, there will be some keywords. If at all I talk about operating system, we talk something on polymorphism, we talk something on deadlock. Those are the keywords. So each and every topic or domain will have their own mandatory or the most commonly used keywords. So we'll see some 10 keywords, which is going to stick in and around digital forensic. That is the know-how part. Why I put it on learn and know-how? There's a main difference. I learn to drive. I know how to drive. So if I come to you and say that you have a brand new BMW or Audi car and you just want to give the key to me to be your driver, you'll give the car to the individual who is saying, I know how to drive. Because there's a main difference between learning and know-how. So learning is knowing the fundamentals. Know-how is typically knowing the bits and pieces of it. So we'll learn the basics, we'll know how it works, and forensic is all about putting into practice, going on to the crime scene, investigating evidence, making a report, producing in the court. That is on the practice part. And finally, for investigation, we'll see the free and publicly available tools and techniques. So this is going to be the take home from today's session. So I've just kept the chat box parallel, hand in hand. So at any slide, if you have any questions, queries, you can very well stop me. You can unmute and speak, or else you can put it in the chat box. Fine. Yeah. So we'll start with the keywords and jargons. As I said, we are going to see some 10 keywords and jargons with respect to cyber forensic. Yes, sir.
Yeah. Go ahead, sir. With
respect to cyber forensic or digital forensic, computer forensic, information security, because these are the common terminologies. Maybe an university might give a course on cyber forensic, another university might give on cyber forensic and incident response. Someone might give on a general banner on cyber security and cyber forensics or not. So we'll start with the basic keywords. You can see here the awkward moment. When you go for a handshake, the other person gives a hug. Two people are meeting for the first time. This is because of a communication gap. They don't know whether to hug or give a handshake, right? So this happens most commonly when we deal with real world cyber forensic cases. Because I'll just put something in the chat box, image, right? So I put something in the chat box called as image. So can someone give me some answers? What comes to your mind when you hear the keyword called image? If you want to unmute, you can unmute and speak, or else you can just some picture. Okay, fine. Someone says it's a picture. It can be a good looking photo. Fine. So any other definitions of image? Okay, 90% of us know it's going to be some pictures, photos, right? So, but I'll give you, for example, at the end of this session, when I say you, hey, come to me, we'll just image the evidence. It's not copying the photos from the evidence. Image is an entirely different keyword, or to be opt, it's going to be the jargon. Jargon means technical term. Image is going to be a technical term, jargon in forensic. I hope at least at the end of the session, when someone says, hey, let's image the evidence, your perception of forensic will be entirely different. So now everyone, we know like image is some picture, a file with some data. Let's say like a picture taken in your mobile, 2 KB picture, 2 MB picture. A picture or a photo taken in a SLR, DSLR, HD camera. It may be 50 MB, 100 MB photo. So image means photo is our current perception. Let's walk on through the slides. At some point of time, you'll know what exactly an image is there in forensics. So you can see here a knife, a lady, not exactly a lady, her hair. So these are the general evidences. A traditional forensic, blood stain, DNA, bullet shoots. We find knife in a crime scene. We find hair particles in a crime scene. So there is a traditional forensics, right? When we talk about digital forensics or computer forensic or cyber forensic, we'll be talking about bits and pieces that we saw on the first slide, right? Zeros and ones, evidences, fine. So we have one small principle which has to be sorted out here, given by Dr. Edmond Locard. He's called as Sherlock Holmes of France, and this principle is called as Locard's exchange principle. Simple words, every contact leaves a trace. So that is called as, yeah, typically tracing a criminal left behind with some footprint. Shortly, we'll see the definition of a footprint also. So every contact leaves a trace. This is called as Locke's exchange principle. This is not only for forensics or digital forensic. This is applicable for any forensic. You take a traditional forensic, bloodstain, DNA, bullet shoots, and on ballistics. Nice. So when we connect this with our digital forensic, every contact leaves a trace. That is obvious. So if you want to expand in a crime scene, whenever someone comes into the crime scene, they leave something. When they go out of the crime scene, they take something. In a traditional crime scene, it can be a knife, it can be a hair particle, it can be a small fiber from your dress or on. When we talk about digital forensic, we know everyone knows about digital crimes, right? Someone have just hacked your account, someone have sent an OTP and got your account, someone have sent a link, you clicked, your system got compromised. So in digital forensic, everything is about zeros and ones, bits and bytes happening with computers, with or without internet. Right? So every contact leaves a trace. In digital crime scene, we'll see how the contacts leave digital traces. And being a forensic investigator or an academician who's teaching cyber forensic, we need to know like how to trace it and get back to the evidences. And this is Dr. Edmund Locke, called Sherlock Holmes of France. Again, I am just continuing my PhD in digital forensics. So when I started writing my problem definition, I just investigated a lot on Edmund's thesis. His thesis is so good discussing about traditional forensics. So he's also called as father of older forensics. Okay. So I'll give you a couple of definitions today. What is digital forensics and what is a digital footprint? Two definitions. After these definitions, we'll get on to the keywords and jargons. Fine. So this is a typical Wikipedia definition. I have taken from the Wikipedia page only, but I have just, for ease of use and understanding, I have just given the variation in fonts. So digital footprint. Fine. So what you see on the right side of the screen, a footprint. What is there inside the footprint? Facebook, Instagram, WhatsApp, different application icons, right? Yeah. So these are the most commonly or publicly available application we use on the internet. Anyone who's attending the meeting won't be able to claim that I'm not using any of these. Fine. Because Zoom is a part of that. We are a part of Zoom. It's also going to be a part of this digital application. We connect via the internet. We search on the Google. We do chat on Facebook, Instagram, and on. Fine. So this is called as a digital footprint. Let's say like today we started, we went to the college, came back, we walked. If you have a smartwatch, it will say, hey, you walked 1,000 foot or 1,500 steps, something like that. So when we talk about digital footprint, from the morning when we wake up till we just sleep in the night, what are the digital footprints we leave on the internet? Attending a call, dropping a call, sending a message in WhatsApp, sending an email in mobile. So these are the digital footprint, the activities which we do on the internet. So a typical definition of digital footprint is summarized like this. It's a unique set because yours thing will be unique from my thing. So unique set of traceable digital activities. You browse, you share, you email, tag someone on the photo, share it on Facebook, Instagram. Your actions, adding, deleting, updating, modifying, something on your Insta, Facebook, emails. Contributions, if you want to add an attachment, mail it to someone. From simple post to advanced recoding. Typically, recoding is something on writing codes for viruses. Very few of us might have heard of this. There are a separate group of individuals those who sit and write virus codes online. And finally, communications. For doing all this either online, offline, with or without internet, we'll be using email and Wi-Fi and on. So whatever actions which we do here are manifested on the internet or on the digital devices. Either we just put it on the cloud, on the device and on. So digital footprint is a unique set of traceable digital activities, actions, contributions, and communications that are manifested on the internet. Manifested means stored, updated, modified on the internet, sometimes on the digital devices. It's not mandated to have an internet. You take a photo and store it in your mobile itself without an internet. So this is called a digital footprint. Keeping this stable definition of digital footprint, we'll get on to the actual definition for the day. I hope at least by the end of this session, if someone asks you what is digital forensic, we should be able to define. Again, just like we just ask students to memorize something or keep in mind hard code, that's not mandated because it's all about understanding, right? So digital forensic is a process of finding and analyzing electronic device. Simple. So you are going to find and analyze electronic devices. And you're going to search. When we started, we are discussing that you're going to search for a photo, you're going to search for an email, you're going to search for an audio, video, anything. So digital forensic is the process. You know process, right? 1 step, 2 step, 3 step. We'll see the descriptive processes shortly. So it's a process of finding and analyzing electronic data. So where we can find these electronic data, we see we have quite a number of devices. Older days, only hard disk was an electronic device, typically capable of storing and retrieving. Maximum came in floppies and CDs and all. Nowadays, camcorders, MP3 players, mobiles, GPS devices on the car, your tablets, on and on. Any device which is capable of storing, retrieving, and transmitting data. You can see here something that is an odd man out that have been here on the left side of the screen. A person holding a remote. Now we are talking about IoT, applications of IoT. You know, small devices, sensors, controller devices. They have internal memory. They have small chips, which is capable of storing the last 30 activities. When we go for real world crime scene investigation, these sort of smart portable IoT devices have been an ample pool of evidence. With that, we can clearly say what happened on the crime scene that date, that time. Fine. So any device which is capable of storing, retrieving, and transmitting data can be an integral part of the digital evidence. So keeping this in mind, we'll get on to a descriptive definition. If someone says like, okay, finding and analyzing is digital forensic, sounds good. Let me brief it, right? So if someone asks you, okay, what is the additional things that's available with this digital forensics? The goal of process, as I said, it's a descriptive process, 1 step, 3 step, or 5 step process, is to preserve any evidence in the most original form. Again, we'll get back to some cinematic things. So we'll go to a movie and we'll see, right? So whenever a cold-blooded murder happens, the police comes to the crime scene, they'll be seeing a person killed with a knife or something. They'll put a pure white kerchief above that and take the knife. What the police is doing, they are preserving the evidence in the most original form, right? Same way, when we are talking about digital forensic, we'll be preserving our digital evidences in the most original form. Let's say you become a forensic investigator. After a couple of years, you have solved 1,000 cases. You have missed 10,000 cases. So solving 1,000 cases is not any problem, right? But if you have taken 10,000 cases, you have solved only 1,000 cases, no issues. But when you go to court of law, the first and the foremost thing, or else we call it as a thumb rule, whatever is has to be followed for sure. The thumb rule in digital forensic is preserving any evidence in the most original form. So you might have heard of normal court proceedings. When we talk about digital related, cyber related court proceedings, the first and the foremost challenge is proving this as an evidence. Let's say you have a pen drive or a hard disk, a mobile phone. Initially, you need to prove to the court saying that, hey, this hard disk or this pen drive or this mobile is the actual original evidence. We call it as primary evidence, secondary evidence, and lots of cyber law part are there into that. So initially proving that as an evidence is the first challenge. Second challenge is going to be proving that as an evidence and saying that the evidence is not modified. Let's say like this crime scene in which the mobile was seized from the crime scene on August 10th. Now it is somewhere on the November. We need to clearly say like this mobile phone was seized in this location and this is the crime scene. And the mobile phone is kept intact without any change and producing in the court after 3 months. Only when we satisfy these two things, proving that thing as an evidence or electronic evidence. Second thing, saying that the evidence is not modified, then only a forensic investigator role comes in. Then we'll say the email was sent, photo was deleted, someone has just done a crime, someone has stolen money, everything. If it is not accepted as an evidence in court of law, your case won't be taken. They won't come into the part of investigation, and whatever hi-fi tools you use, they're least bothered, right? So the first and the foremost rule in any digital forensic or cyber forensic is preserving the evidence in original form. So we'll see some technical terms, how to do it in the upcoming slides. So after preserving the evidence, we do a structured investigation, going to the crime scene, collecting the evidences, identifying what all the bits and pieces, what is in the hard disk, what is in the pen drive, what is in the cloud, and validating. Okay, if we say it is a photo, okay, this is a photo. If we say it is a PDF file or document, this is a document, validating the evidences. After doing all these things, then we'll get onto the crime scene. I want to prove last Friday, this guy using this laptop, using Gmail, have sent a mail. After sending the mail, he deleted the email, he deleted the document in the downloads folder. So this is a typically step-by-step process in any digital forensic investigation. We are doing all these things for the purpose of reconstructing a past event, right? Typically, you see in movies, right? Someone might have been murdered. In the movie itself, they'll show it 10 times. Rewind, and show how they murdered, how the guy or girl got murdered, right? So typically, we are reconstructing the past events happened on the digital devices. The ultimate purpose of doing all these things is to prove it in the court of law. So when we combine all these things, typically if you take the black part, preserving the evidence in the original form and doing an investigation to reconstruct the evidence or reconstruct the past event is called as digital forensic or cyber forensic. So if we take it as a complete consolidated definition, reading all together, the goal of the process or goal of this investigation process is to preserve the evidence in most original form. You solve the case or not, that is secondary, but you need to preserve the original evidence in the original form while performing a structured investigation, collecting, identifying, validating. It's typically for the purpose of reconstructing the past event. The same flow, whichever we have just seen in birds, have been given in the data flow diagram, as you can see here. Identifying the evidence is the first thing. Many people tend to collect the evidence, go to the crime scene, remove the hard disk, remove the pen drive, copy that. That's not a forensically sound practice. Forensically sound practice is going to the crime scene, identifying the evidence, preserving the evidence, then collecting the evidence, then come back to your forensic lab, use a free tool, use a paid tool, processing the evidence, reviewing the evidence, analyzing the evidence, then production, typically production of a forensic report. Finally, if they call you to the court of law, you go as an expert witness and present it in the court. Hey, Your Honor, so I am the investigator. I investigated the case. This was the email, so it was deleted. Without modifying the evidence, we have made the forensically sound report. Right? So starting from identification till presentation, it's a complete consolidated step-by-step careful process, which we call it as a forensically sound process, which means not any error, not any mistakes are done by the tool, technique, or humans in the due course of the investigation. So this is about digital forensic. I hope at least by the end of this session, right? So everyone will be able to give a definition of digital forensic: finding and analyzing evidence, preserving in original form, investigating, reconstructing. These are the bits and pieces. So with this, we'll just jump on to the keywords. I'm taking a case abstract from a case. You can see at the bottom, it's a 100-page report of a case. I've taken page number 7, a couple of paragraphs, a single paragraph. This says, Mr. Seglia claims to have copied and pasted a text from a purported email that were backdated. Being a forensic investigator, when we make a report or you write a forensic report, you read a report, we need to clearly understand that. This is not a novel. You read, write, and you don't understand a paragraph, you go and read the next paragraph. We need to know the bits and pieces of each and every thing that have been written on the report. So purported email and backdated. These are the two main keywords. Purported email means it's typically a fake or forged or maybe a duplicate or something abusive emails. It can be wrong date, wrong time. It can have a different attachment, right? Something is not normal. That's called as a purported email. And it clearly says the email had a Word document. The Word documents were backdated. Simple. I'm creating a Word document of salary statement. We used to investigate many cases on corporates. An employee says, hey, I worked for this company before 6 months. They'll give you a salary statement from SBI saying that he got like 70,000 salary. But that may be actually a fake cooked document. He might have got 40,000, but he might have just changed it and modified it. So typically this Word document clearly says the document was created 1 month before, but actually the document claims it was created 6 months or 1 year before. This is only a simple paragraph I've taken from this abstract. So being a forensic investigator, if you want to pursue a career, if you want to teach something on forensic, we need to know bits and pieces of digital forensic. So we'll start with the first keyword for the day. I'll quickly walk you through the 10 keywords. Fine. Then we'll see what exactly we'll just understand on the investigation part. File carving. Fine. Okay. So just a minute.
Yeah. Excuse
Yes,
me, Ashok sir.
yes,
Dear faculty members and all the students, I request please pay attention now because these are the very useful keywords which sir is going to discuss now. So please pay attention. This will be very useful for to understand what exactly digital forensics is. Yeah, go ahead, sir.
Okay, thanks.
Thank you. Thank
So,
you, sir.
so we'll start with file carving. So everyone knows, right? So if at all you go for a non-technical event, we talk about vegetable carving. You take a watermelon and carve it, remove some pieces and say it's like a peacock, right? So that's how we do a vegetable carving. So let's imagine like a file carving. You have been given a file, a big file. Let's say a pen drive that is corrupted. This sample case which I have taken is typically a corrupted pen drive, in which a file is there. Let's say some Word document is there. The pen drive is formatted multiple times. You want to take the actual Word document or the photo, right? So file carving is a practice of searching an input for files and other kinds of objects based upon the content rather than metadata. So we have two contradicting keywords here, content and metadata. Content is actually your data. Metadata, hope everyone knows, it's data about data. We'll see metadata shortly. So now we say, so whenever you take any file, audio, video, text file, any file, it will be having the file content. Let's say it's an MP3 file, 5 MB MP3 file. So 5 MB MP3 file is the actual content. There will be some small KBs of data called metadata, right? So in this example, what we are doing, any file will have a file content and the file metadata. In this example, file metadata is missing or deleted. Nowhere the metadata is there. So the challenge for a forensic investigator here is to analyze the evidence and get it out only with the file content, right? Metadata is not there. We'll see why metadata will be useful in a couple of slides. So I'll show you an example. You can see here. Yeah. So what is a document given here? Can someone give me in the chat box? So what does the document looks like and what is inside this? Anything you can type on the chat box, whatever you feel, how it looks like. Because we are working day in and day out, right? The layout, the format which you see on the screen. What is this one which you see on the screen? Any guess?
You can report in the chat box also.
Yeah.
Or you can unmute yourself and you can say, please. Minions.
Yeah, you see a minions here.
Minions.
Yeah, you see a despicable me. Actually, it's typically a Word document, right? So inside a Word document, yeah, image and some text that is inside a MS Word document. It can be any type of Office document. We take it as an MS Word document. In this example, the pen drive had a Word document. The Word document had some wordings. Inside that, it had a photo. All these things has been deleted. The pen drive has been multiple times formatted. The pen drive comes to the forensic lab. If this is a Word document, let's say this is a despicable me.docx, right? So despicable, sorry, I'm typing in the chat box, despicable me.docx. So if this document is available, we can easily open the document, recover the document and see. But the document is not available. It's already formatted multiple times. Just like you take a paper, tear it into 20-25 pieces and put it on the ground. So what we need to do, we need to take the correct bits and pieces and reconstruct it. That's what we're going to try here. So when the pen drive is formatted, you don't know what is inside that, but we clearly know there is a photo. I want to find a photo that is inside the thing. So you can see here, the tool which is given here is HXD. We call it as hex editor. When we talk about hex editor in forensic, I can give you a comparison like an X-ray machine. What an X-ray machine does, you go, you scan your body, you scan your face, you scan your tooth, it will clearly give what is inside. So hex editor is typically a forensic tool which will give you any data you give, normal data, corrupt data, half-baked data, mixed data. It will give you the bits and pieces. What is inside that, it will show you, just like an X-ray machine. So what we are doing, we are taking the pen drive, we are taking the contents of the pen drive, and we are putting it into this hex editor. In this example, we have already extracted the evidence document. We are putting the document into this hex editor. As you can see here, evidence.doc. So the document is taken and it is given to this tool called HXD, hexadecimal editor tool. So now I'm searching for something, right? For example, if I say there's a document called salary.pdf is available in my desktop, what you will do, or downloads, you open the download and search salary PDF, right? Same way, we are going to search for a keyword. Fine. So I'll give you some jargons. Magic keyword. I'm typing in the chat box. This is a magic keyword, one of the technical term which we use in forensics. So what does a magic keyword says? So it will clearly use to identify something. This is a magic keyword. FFD8, FFE0, which will clearly say whether it is a JPEG or JPG. It's a photo format. It's a typical image format. Fine. So I'm searching for this. I don't know what is inside the document, but I clearly says like I want to recover or retrieve the images or photos inside this evidence. Fine. So FFD8, FFE0. Again, I'll just type it in the chat box. If you want, you can just go and Google for this keyword. It will clearly say what does it mean in forensic word or magic keywords. So if I'm searching for this, it says like 4 result found. The conclusion is inside this Word document, there are 4 photos. If it says 1 result found, the conclusion is inside this evidence document, at least one photo is there or image is there. You can see here, offset number 14FD. Again, I'll give you a real world example. You can imagine this to be a movie theater. Offset and some data and right side. Offset is typically, you can imagine it like your chair number. 1490, 14A0. This is hexadecimal equivalent. So it will be from 0 to 9 and A to F. 0 to F is 16 characters, right? So it says like offset number, you can see here, it says like offset number 14FD. Whatever magic keyword you are searching for a photo is available on the offset number 14FD. Let's go. 14F. F0, F1, F2, F3. Let's walk through, right? F0, F1, F2, F3, F4, F5, F6, F7, F8, F9, not F10, FA, FB, FC, FD. We got it here, right? So in 14FD, it clearly says FFD8, FF, and in the next line, you'll be able to find the E0. It clearly says whatever you are searching is available in this offset number, just like chair number we say, right? So it's available in the offset number. Now we have concluded saying that, hey, inside the evidence, there's a photo. Then what will be the next challenge? I want to recover the photo. I need to know where the photo starts and where the photo ends. If it is a contiguous, sometimes it may be on different locations or not contiguous. Let's assume this to be contiguous. Contiguous in the sense it's going to be series. 1000 bytes, 700 bytes, continuous order. Right? So the next challenge is finding starting of the offset. If I know it is a JPEG, you can clearly find we have some magic keywords to find 14FD and 2ADB. Right? So these are the keywords associated to JPEG. So once when it is done, what we can do? We can copy the location, put it in a notepad. We already know it's a photo. Go to the file and save as recover image.jpg. So if you have recovered in the right order without missing any bits and pieces, we'll be able to reconstruct the photo. So this is typically called as file carving. Just like we do a vegetable carving, this is a file carving. We know we have a bunch of data. We know what we need and what we don't need. We separate it both. What we need, we give it a correct file format, save it, we get the actual evidence. All these things are done without the help of metadata, right? We'll let you know what is metadata shortly. So this is called as file carving. It's a practice of searching an input. Here we are searching for a chunk of data from pen drive or other kind of objects. We are searching for a JPEG based upon the content. We went on to the data just like an X-ray machine. We found bits and pieces. We found the magic keyword. We found the starting offset. We found the ending offset. We have clearly recovered the evidences. Fine. And disk image or disk imaging. I hope we started with the discussion on what is an image, right? So many of us had a perception saying this image is a photo, right? I'll take you to something like this. So what we see here in this screen, 1, 2, 3 different types of photos. So can someone comment on what is there on the 3? Whichever is at the bottom, right? BMP. BMP is typically a photo format, bitmap photo, right? At the top, what we see, ISO. So you go and download a Windows 7 OS, Ubuntu OS. They give it as an ISO. That also we call it as an image. You say like, hey, I want to install Kali Linux. I want to install Windows 7 in my laptop. So your service engineer will say, hey, bring the ISO image of the Windows OS. So normal images which we know in traditional world is an image that can be a photo and another image that can be a bootable CD or DVD or a software that's used for making that. But in digital forensic, image is something like this. So can someone comment what you see on the screen here? What is this and how it looks like?
Yes, participants. What is this image?
Copy of disk. Yeah. If someone is
Hard disk.
hard disk. Sounds good. So if you are seeing this for the first time,
Hard disk.
this is a autopsy version, dismantled version of a hard disk. When you open a hard disk, we see something like this. So how many hard disks we find here? We see here numbers, quantity. 2, a couple of hard disks. So we see one on the left side of the screen that is going to be fully dark, like full size, and right side is a bit of blurred. I made it blurred to show a differentiation. So let's take an evidence. You have an original hard disk and you make a copy of the hard disk, exact bit by bit copy. So this is called as image or imaging in forensics, right? So if we call it as imaging in digital forensic, it is not a photo, it is not a CD or DVD. Imaging in digital forensic is taking an exact bit by bit copy of your evidence. Your evidence can be a hard disk, it can be a pen drive, it can be a cloud data, and anything. So hereafter someone talks about imaging in forensic. If I say like, hey, image the hard disk, what you need to do? You need to make an exact copy of the hard disk. We'll see some additional parameters, how to make the image forensically sound, or how to prove it in the code saying that this is the correct evidence. Fine. So now we got an idea. Image or imaging in digital forensic is an exact bit by bit copy of your evidence. In real world, we can compare it to a cloning, right? You know cloning, right? Cloning something, or duplicates, or twins, right? It's an exact copy. So that is called as disk imaging. Fine. So you can see here, creating a sector by sector copy of the source medium. So sector by sector, you can imagine, like if you go to a theater, you find 100 chairs. So the atomic part is one chair, 1, 2, 3, 4, and you have 100 chairs. When we talk about digital data, hard disk, sector is the smallest atomic unit. So one sector, cluster, bytes, kilobyte, megabyte, gigabyte, it goes on like that. Physically, we call it as a sector. So your hard disk may be made up of, if at all you get a chance to see a hard disk, on the top of the hard disk, there will be a sticker. The sticker will be saying a lengthy 10-digit, 12-digit number, 1, 2, 3, 4, 7, 7, 9, 9, 4, 4, 6 sectors. What does that mean? In that hard disk, those many sectors are there. So when we talk about disk imaging, creating a sector by sector without even missing a single sector, because below sector, there is no atomic unit. So without missing a single sector, we are going to copy the source medium. That is the evidence. Fine. Then the next thing, we'll have a question, right? So in the first definition, we saw whether you are solving the case or not, that is secondary. But the challenge is you should not modify the evidence, tamper the evidence, right? So then what can we do for this, right? So there is something called as a write blocker. I'll give you another real world example. One-way traffic. What does a one-way traffic means? Can someone say, unmute and say, you leave these technical terms, a typical traffic, one-way traffic in a road. What does a one-way traffic means? Or one way?
One can go on one direction only.
Okay, as per the protocol, as per the traffic rules, we can go from left to right and not right to left, or vice versa. You're allowed to travel in one direction, but you're not allowed to travel in other direction. We don't follow this. If at all there is not a cop standing there, if there is not a CCTV, we violate it, right? That's general. But with respect to the protocol, one-way traffic is allowing traffic to move from one direction to other. So let's take this disk imaging. What we are doing, we are taking a, let's say you are taking an evidence from the crime scene, 500 GB hard disk, 350 GB full, fine, out of 500. You are copying the 500 GB hard disk to a empty hard disk. So what we are doing, we are copying from the source medium to the empty destination medium. So while copying, we need to make sure like 100% of data should be copied. That is one challenge. Second challenge is we should not copy anything into the evidence, because we saw the definition, right? A single bit is modified in the evidence, the code, they won't accept it. Fine. So acquisition without damaging the source. Read only, no write access. So for the source medium, anything you can read out of the evidence, you don't write anything on the evidence. This happens. I'll give you an example of virus. So most of us might be having a pen drive or had a pen drive which was infected by a read-only virus. What does it mean? It might be a 16 GB pen drive. You have 8 GB data. When the virus is infected, it will make the pen drive read-only. What's the conclusion? You can copy anything from the pen drive to your system, but it won't allow you to copy a single bit from your system to your pen drive. Even if you have 8 GB free space, it won't allow you to write anything. That is typically called as write protected, write block. Fine. So in forensics, we have some hardware like this. I'll show you a real world write blocker. I hope as Sir mentioned yesterday when we were there on the Interpol forensic meeting last week, we found all forensic commercial vendors. These were coming and showcasing their write blocker capabilities, which write blocker to buy and what is their power and how it is proved in the court and everything. Tablet, most commonly used hardware vendor who sells write blocker. What is the purpose of write blocker? A single image can explain you the whole thing. You can see here on the right side of the screen, it's a hard disk. Left side of the screen, an empty hard disk, typically a removable portable hard disk. And you have a workstation, a computer, and something additional is here. You see here, a small hard disk like box with some LEDs. This is called as a write blocker. So what we are having between the source medium, that is the evidence hard disk, and the destination medium, empty hard disk, that's a workstation computer which is going to facilitate, and it is connected to the write blocker. You can see here, your source medium is directly connected to the write blocker to your computer, then your computer to the empty medium. So if the write blocker is going to work good as per the protocol, the write blocker won't allow any data to be overwritten on the hard disk. It can copy 100% of the data from the right side and move it to left side, but it won't allow a single bit of data to be copied from left side to right side. So if you're going for a forensic investigator and you do a imaging, you go to the court and say, if at all a technical person is there, they'll ask how you can make sure like this data is not modified. You'll say, hi, I used a tablet write blocker. It's an ISO NIST approved standard. They won't be able to question you, right? So this is called as write blockers. So we are imaging an evidence, disk image, second thing without making any change, that is write blocker. Even now the opponent or the opposition, those who defend on the court, they are not convinced. They'll say, hey, you might have made changes. You might have added a photo and saying that this is my client photo. I don't believe you. Then how to prove them? That's a technical term. A basic, if you have just been comfortable with cryptography, encryption, decryption, locking, unlocking. There's a algorithm function. It's an algorithm we call it as a hash function called as hashing that can map data of arbitrary size to a fixed size. Let's say like you have a 1 KB text file. When you hash it, you'll get a 32 character output. You have an MP3 file, 5 MB MP3 file. You hash it, you'll get 32 character output, but unique output. You have a 4 GB HD video. You hash it, the hash output will be 32 character. If at all you're taking MD5 as a hash algorithm, right? There are many hash algorithms available. Fine. So then if you're imaging the whole hard disk, 500 GB hard disk, the output will be 32 character. As you can see here on the right side of the screen, if I'm not wrong, each row will be 8 character, 8 into 4, 32. So this is equivalent to, or this is says like the eagle flies at midnight. That is the input. We have an algorithm called MD5 hash algorithm. The output is going to be an hexadecimal equivalent. Fine, it's a hexadecimal value. So, but this hexadecimal value is so unique for the keyword. If you type your name and hash it, you'll get an hash. If I type your same name and do the same hash, the hash will be the same. Conclusion is, it's typically not a compression or zipping algorithm. Generally, we used to misinterpret. We are not going to recover the old file. It's not doing a zipping or rar or archiving forward. This hashing is typically making a signature, you know, right? You write a document and give your sign. So unique. Just like you take your example of your thumb impression, thumbprint, fine? So this hash function is going to be the output of your evidence. Let's take an example here. Dog, the brown dog runs down the hill, the brown dog leaps down the hill. You see the hash algorithm? The hash function completely changes. Starting from 8830, E7172, different. So you need to compare two hard disks. So what is the conclusion of these two hard disks? Can someone comment on this? Hard disk above and hard disk below, before and after we have taken the hashes. So can someone comment on this?
It may be store the address or create a replica.
Yeah, so we are creating the hard disk. Let's say like this is the original hard disk, source hard disk. So we take the original hard disk, we take the hash of the hard disk. So this is the hash starting from M7 and ending in 89. So we do an imaging, we write a write blocker, and after that, in the second hard disk, we take the hash. If both hashes are matching, what is the conclusion? Without making any change, we have copied the 100% of the data from the
Integrity.
source medium to destination. Yeah, that's absolute. We talk about CA, right? Confidentiality, integrity, availability. This is the integrity. The integrity of the evidence is not modified. So this thing we will be proving in the court of law. So for this, there are many hash functions available. MD5, SHA-1, SHA-2, Tiger, quite a good number of hash functions available. So when you go to the crime scene, we take the hashes, something like this. See, this is a hash checker tool. You can take a hash of a text, you can take a hash of a file, you can take a hash of the whole hard disk. So before and after, if the hashes are matching, conclusion is the integrity is not challenged. It sounds good. I can see here whenever you go online downloading a bigger file. So Ubuntu websites, when you go and download their file, so they'll give you the ISO file and they'll give you the corresponding hash function also. So hash output also. So when you download the file, you can verify you are downloading a 4.2 GB bigger file. After downloading, open a hash calculator, calculate the hash, verify the hash. Even a single bit of change, the hash will be completely changed. Right? So now what we have done, we have imaged the evidence, we have used the write blocker to make sure nothing is modified. We have verified the hashes also. So this piece of evidence we called in court of law as a forensically sound evidence, right? So if this is not done, any investigation we do further won't be accepted in court of law. So we are talking about imaging, right? So I'm imaging a 8 GB pen drive. I'm imaging a 500 GB hard disk. What will be the output file of the image format? Can it be a PDF, PPT, document, Excel sheet? No. Image in digital forensic is having specific format, just like we talk about PPT, PDF, right? E01, A01, I'll show you the standard formats. Yeah. RAW, DD, E01, BHD, these are all the different digital forensic image file formats. Just like we talk about JPEG, document, Excel sheet. RAW is the most commonly used file format without metadata. DD is the most common file format that is used in any Unix and Linux computer. E01 is an encased file format. It's a commercial paid tool. DMG is the image file format that is used on MacBooks, Apple devices. VHD is the image format used on Windows. So when you see any file name.e01, file name.dmg, file name.vhd, you can conclude that there is a image. It might not, sometimes it might not be a forensic image, but that's a chunk of data. Let's say 8 GB, 500 GB, 1 TB. So this is called as a imaging or image file formats. Right? After this imaging, we get on to a part called as an affidavit, something related to your cyber laws and court proceedings and all. Yeah. Mom wants me to write an affidavit. Couldn't be used because I'm a minor. You know, right? We used to make kids write an affidavit, not exactly an affidavit, write something in a paper saying that, Mom, I won't break this or I won't spill the water anymore. But the next day they'll repeat the same offense. We cannot prove it, go and put a case against them in the court, right? So it's a general paper writing. Affidavit is an exact opposite of this. Affidavit is a formal written document that memorializes or has the complete content, declaration of the fact by the witness. So let me show you a sample affidavit. State of Texas. Affidavit is given by JNH Doe, a person. He's a network administrator of the company. He is giving a written statement saying that, hey, this date, this time, Sarah Smith, an employee from our company, he took the computer, it may be a laptop or a computer, out of the company. And he's giving the date, sign, seal, notary public, you know, right? So when you go for a attestation, you go for a notary public, greening sign. So affidavit here is a written declaration. So when you go to the crime scene, you see a hard disk, you see a pen drive on mobile. After 6 months, they come to the court and say like, hey, that is not my hard disk, that is not my computer. I didn't give it to them. So whenever you go for the crime scene, you take some evidences, you take some affidavit. So you might have seen in movies, right? Big shots in which you go and raid their house. So the CBI officers or someone will be getting an affidavit at the end. Hey, I have stated whatever things, this many amount of gold, this much amount of documents, these many hard disks I'm taking from your home. You get a sign from them, you seal it, you get a notary public, then only it will be accepted in court of law. So whenever we talk about affidavit in forensics, it's going to be a typical written statement signed and sealed by a notary public and with a couple of witnesses. Fine. So this is typically a search warrant, sample search warrant affidavit. And affidavit changes from country to country. This is an affidavit from UK. So Indian affidavit will be something different. So this affidavit says who's the signing authority, what can be done and what not to be done. Yeah. Now comes metadata. You remember metadata? Where we heard of this before some time? While discussing on? Any guess? The first keyword which we started learning today. What was the keyword? Vegetable carving, right?
Yes.
Yeah,
File carving. File
So
carving.
we talk about file carving. We reconstructed a photo minion image from the corrupt pen drive because we don't know the metadata. So metadata is the easiest among any engineering course, right? Easiest to mark. Metadata is data about data. So what will be there in metadata? You can see here, data about data is called as metadata. Metadata, typically we are searching for a metadata of an evidence. Evidence can be an audio, video, document, photo. In this example, we have taken an example of a photo. You can see here how the photo looks like. A couples standing on the mountain and doing a romance. Who are they? How they look like? The so-called terrorists, right? So if we get any images like this, again, I throw you a disclaimer because metadata is my core research area when I do my PhD and all, right? So if you copy something on your Facebook, WhatsApp, Instagram, social medias, they used to tend to remove the metadata. You cannot get the metadata as if when you just copy some images and put it on your social medias, Instagram, WhatsApp, and all. So if you are taking in a digital camera, if you're sending it in email, you're sending it in some other medium, the metadata will be intact. So metadata is data about data. So whatever you see here, EXIF, EXIF, EXIF is a standard protocol, right? Which will have a series of metadata. So this is a photo taken from a Canon EOS 450D camera. Resolution, make, model, the date in which the photo was taken. If the GPS is enabled, it will clearly show you GPS location. So you open maps.google.com, type 36.16N and 69.96E northeast. So it will clearly show you somewhere a mountain range on Afghanistan. Because this photo claims that it has been taken on a mountain in Afghanistan. So metadata in digital forensics, typically it can be a photo, audio, video, any evidence. Metadata is typically data about data. In technical terms, here we call it as an evidence about an evidence. This is a photo, JPEG, camera, make, model, time, when it was created, when it was modified, all additional information. Metadata is not actually a part of the file. If we say 4 KB file, metadata will be some additional header. It's not going to be an actual file. So when you hash the data, when you hash the evidence, if the metadata changes, the hash won't change. Keep in mind. Fine. So metadata is typically data about data. MAC timing, here we see MAC, when the file was created, when the file was modified, when the file was accessed, that is called metadata. Fine. So now let's jump on to another guy, the interesting guy who have been seen. Philip Budakin. Fine. Any guess on who's he? We know our celebrities, right? He's also a celebrity in digital world, cyber world, good or bad, right? But somehow he was a celebrity. So hope most of, yes, sir.
Make some of the bank accounts and give this money to needy people.
No, you're not audible, sir. Can you come again, sir?
Means he's hacker who hacked some of the accounts and steal the money and distributed that money to the needy people.
Okay, sounds good. So SAT claim is like this guy, Philip Budakin, maybe a Russian guy, is a hacker. He stole the money. He distributed it. He just stole the money from bank or some people. That's what a general typical hacker looks like. He's also a criminal, but not on the hacker category, not on the financial fraud hacker category. So I'll give you some hints, right? So what are the games which our kids used to play these days? Can someone comment on the chat box? Games. Interesting games. At least we would have heard of the games which our kids play. Pokemon Unite sounds good. Any other game? In mobile, online, Free Fire, PUBG. Sounds good. So can you name some interesting game that is going to be life-threatening games? Again, GTA, PUBG also life-threatening. If we rewind back and go before 3 years and 5 years, any yeah, Blue Whale sounds good. This guy, Philip Budakin, is a proclaimed founder of Blue Whale. He's a research guy. He was a PhD guy. His PhD output was Blue Whale game. That was so interesting, right? So he said, like, I made this Blue Whale game for people, those who don't want to live in the world. They are not allowed to live. They don't have a right to live on the world. Everyone knows Blue Whale challenge. They'll give 50 challenges. First challenge will be take a blade and cut your hand. 50th challenge will be go to the roof and jump from the roof, right? So these sort of people, in technical terms, in cyber terms, as someone was mentioning about someone who committed a crime. So another guy like him might be robbing a bank using online. Another guy like him might be sending you an OTP and steal your money. All these people are categorized as perpetrator, right? So in technical terms, when you read an affidavit or something, when you read a forensic report or something, we come on to a keyword called perpetrator, perpetuator or perpetrator. It's typically a person or individual or a group who carries out harmful or illegal or immoral act. It can be an insider who's working with you in the company. It can be an outsider, so-called hacker. It can be a disgruntled employee who recently left your company. Competitive intelligence, you know, right? Apple is suing on Facebook. Gmail, Google is suing on Microsoft. Companies are just spying on other companies. State-sponsored, you know, Indian Cyber Army, Pakistan Cyber Army. Cyber terrorists, many terrorist groups do cyber terrorism online. Hacktivist, you know, hackers, right? Anonymous hacker, cyber hacker, different hackers, all these categories. Anyone who does something offensive using digital data are going to be categorized as perpetrator. See, Philip Budakin is a perpetrator of a creating and propagating Blue Whale game. Fine. So a couple of confusing jargon. So I put them on the same slide. Slack and swap. Two technical terms, two definitions. Slack space. Let's again take the example of the same movie. You book 4 tickets, you, your wife, your daughter, and your son. So your wife is there, your daughter, maybe an elder one saying that, hey, Papa, I'm not coming. I'll take a break. I'll sit in home. So son might be a small kid. So when you book 4 tickets, only 2 people, 2.5 people are available. What you do? You go there, you take the first seat, second seat completely, third seat partially you take, fourth seat is empty. But what we do? We don't allow anyone to sit. Even if our daughter is not coming, no, this seat is reserved for me. So that is the same case when we talk about slack space. In computer terminologies, slack space is the leftover storage. So when you go and create a Word document, you create a PPT, you create a PDF file. So computer terminologies, everything will be in terms of zeros and ones, right? Binary, 2 possibilities. So in computer terminologies, it will be on 2 to the power 0, 2 to the power 1, 2, 4, 8, 16, 32, 64, 128 in multiples of 2 to the power something. So if here it's 2 to the power 2, 4, right? So if you want to create something, your hard disk or your operating system is giving you 4 sectors. Let's take it in terms of sector, the smallest unit. So you're using only 1, 2, 3, 3.5 sectors. What is the conclusion? So 2.5 sectors. You have been allocated 4 sectors. You are using only 2.5 sectors. Unless and otherwise you delete the file, inside the file, the unused space will be there. You can imagine like day in and day out, many cars, bikes, vehicles are going on the road. Not all of them are fully occupied. Some empty space, unused space is there. So what the attacker will do in this terminology, he'll find each and every file of audio, a video, your hard disk, your partition, each will have their own slack space. Whenever an attacker or hacker wants to act intelligent, they'll find the slack space, the left or unused space, and they will store or hide some data, sometimes virus, sometimes secrets on them. So when we do a forensic investigation, slack space forensic is an entirely different research area in which I know like some of my students have done some research. We have published papers together even. So slack space forensic is an interesting area in which you find some interesting data, malwares, hidden evidences, something on that. The next keyword will be swap space. You know swap, right? Swapping in and out of you. I swap on behalf of you, you swap on behalf of me, right? So you talk about RAM. Computer will have a RAM. So swap space is typically a copy of your RAM. So when you go for a crime scene, someone is browsing something. On seeing us, suddenly they turn off the computer. What does it mean? The browsing, whichever they have done, might be already closed. When you turn on again, that won't be available. But the copy of the browsing habit, something will be left out on the RAM. If the system is turned on, a copy of the RAM will be available in your hard disk. So that is called as swap space. If you are a Windows user, you go to C:, you will find two files, pagefill.sys, hyperfill.sys. These files is typically going to be a copy of your RAM. If you have a 8 GB RAM, 6 GB was used before you shut down the computer. Whatever temporary data that is available in your RAM will be available here. So swap space is going to be a rich pool of evidence for a forensic investigator. Real world, when you talk about malwares, viruses, swap space will give you quite a good number of evidences about the existence of the virus or a malware or a temporary file. In advanced terminologies, when you talk about crypto keys, the keys, temporary short-term keys of the crypto will be available only in your RAM. Right? So these are the two keywords, confusing keywords. So I put it on the same flag. Slack is the unused space of your evidence. Swap is a copy of your RAM. Fine. Chain of custody. From the first, we are talking about taking an evidence, analyzing it, making the report and everything. So chain of custody is typically a chronological document. We know chronology, right? Boy meets a girl, falls in love, gets married, general order. World War I, World War II, XXX goes on like that. So chrono means something putting in the order. When you make a resume, right, we put it in the reverse chronology. Hey, I did a PhD. Before that, I did MTech. Before that, I did BTech, my 12th and 10th. I follow some order, right? That's called a chrono. So this is typically a chain of custody document worksheet. In real world crime scenes, it's a big case having like 4 or 5 evidences. The case was there for 3 months, 6 months, right? The chain of custody document might be 1,500 pages bigger document, because chain of custody is a step-by-step tracking of your evidence. See, recovered by, received by. I get the evidence from Chennai. I take it to Hyderabad forensic lab. From there, I send it to Delhi lab. From Delhi lab, it comes back. From Hyderabad, again, I send it to Mumbai lab. From Mumbai lab, it comes back. So step-by-step tracking of the original evidence. Not exactly the original evidence in most of the scenes. We'll be taking the copy of the evidence. We saw, right, imaging. We'll take the original evidence, image it in a forensically sound manner, make 3 or 4 or 5 or multiple copies, and then use the copies. And keep in mind, when we do imaging, we don't touch the original evidence. We do an imaging, we take 2 or 3 multiple copies. The original evidence and the first copy will be stored in a box, stored in a container, and to be proved in the court. Second copy will be given for the opponent, because the opponent whom you are suing the case also have the equal right in the court of law. The third copy will be the investigator copy. Fine. So all these things, you can see the tags in crime scene. You take a hard disk, put it in a bag, you put a chain of custody, evidence tag. See, submitting agency, case number, item number, date of collection, location, typically a lightweight affidavit, right? It will be signed and sealed and preserved. So chain of custody is a chronological document which will descriptively say from the crime scene till the court proceeding what all the activities done by the forensic investigator on the evidence. Right? So these are the keywords. We saw something on file carving, write blocker, hashing, chain of custody, yeah, different things. So these 10 keywords are the mandatory take home. If we go out and claim that, hey, I know something on digital forensic, we should be able to give a clear-cut definition with examples of these 10 keywords and jargons. So now we'll map these keywords and jargons. Yeah. So we talked about steps, right? Step-by-step process.
Yes, go ahead, sir.
Yes, sir. Do we need a break, or like we'll continue with this, sir?
Let me ask to participants. Participants, is it okay to take a break or should we continue? Let's do one thing, sir.
Yes, sir.
We'll take 5 to 10 minutes break. Then we'll again come back, sir.
Sounds good, sir. So, but the participants need to promise you'll come back, right?
Yeah.
Okay, sir. Fine, sir. Then we'll take a short break and we'll be back, sir.
Okay, in your presentation, sir, you can start the timer also, sir, so that we can.
Yes, sir.
Again.
Anything is fine. Yeah, yeah. We'll make a 10 minutes break. Fine.
Yes, yes, sir. 10 minutes.
Yeah, sir. Fine, sir. Okay, sir.
Okay, okay. Respected faculty members and students, we are going to take 10 minutes of break. Please, we are expecting you to come back again because again, sir is showing you the different scenarios on the digital forensics, so it would be very helpful to you. Yeah.
Yes, sir. I put a 10 minutes break timer.
Okay. Okay, sir. Done. Thank you so much, sir. Meanwhile, you can write any questions in the chat box. Get refreshed. We are having a 10 minutes break. You can write any suggestions, feedback, or any questions in the chat box.
Yeah. Yeah. Meanwhile, participants, if you have any queries, you can write it in the chat box. So after the break, we'll come and see the steps in digital forensics. We'll see the tools and techniques. At the end, to take home, I'll show you a small syllabus, 1 credit course, which can be made for academic things. And if time permits, we'll show you some demo on the tool also. Fine. Thank you. We'll come back after 10 minutes.
Sure,
So I'll be
sir.
active. Any questions in the chat box, I'll happy to answer.
Yes, sir. Yes, sir. Yeah, sure. Thank you so much, sir.
Okay, we have 2 minutes more. Meanwhile, the participant resumes. I'll answer a question from the chat box. Hope I'm audible, right?
Yes, sir. You are audible, sir.
Yes, sir.
Please
So there
go
was
ahead.
a question in the chat box on how easy or hard is to gather evidence on the latest system. If you're talking about any of the current day IOD, SCADA, real-time systems on the cloud, it's really challenging for a forensic investigator. Older days, traditional, before I still remember going before 10 years, going to the crime scene, taking the hard disk evidence, max to max, you have a CD, DVD, floppies. That's it. But nowadays, you go to the crime scene, it's typically a nightmare. We don't know where the data is stored. Pen drive, keys, watches, traps, different devices. So it's really challenging, but bits and pieces are connected. So when you go for any real world forensic investigations, being a forensic investigator or a first responder who goes onto the crime scene, we'd be trained on just knowing different evidences, just like each evidence which should be handled differently and imaged in a forensically sound manner and taken onto the crime scene. Some evidences we won't be able to image it as such. Maybe the current systems that is running on the servers, we won't be able to turn it off. We need to take a live imaging of the evidence. It goes on. So it's really challenging, but we still have to work on that, right? We cannot just close the case and go on. Yeah, I hope the time is up. So we'll just resume with our things. Again, as you're talking about this imaging and the things, there are current day paid version of the tools, sophisticated tools. I'll list you a few at the end of the session. So they are capable of doing. If you say like I want to image the cloud, Google Drive, Dropbox, something like that, they have customized tools that comes under standard, that comes under protocols, policies that can be forensically sound proven in the court of law. Fine. Yeah. So saying this, I'll just resume our session. Steps in digital forensics. So there are 3-step, 5-step, 7-step model, different models. This is my own perception. I have made my 4-step model of digital forensic investigation based upon my teaching and the investigating experience. Yeah. So Caesar, acquisition, analysis, and reporting. Whatever we have seen till now, we have summarized it into a structured model. Yeah. See, we see what exactly is Caesar. You know, right? You see something from the kid. Nowadays, we do seize mobiles from the kid, right? Hey, stop it. You take your food, right? Seizing is taking something forcefully. So why this terminology is given? Anyone who committed a crime won't give their devices. Okay, take my device, sue me on the court. I'll go behind the bars. No. So Caesar is typically will forcefully take the evidence from the convict, those who committed a crime. So that's called Caesar, general terms. So identifying the probable evidence, acquiring appropriate warrant from law enforcement agencies, you know, right, search warrant, Caesar warrant, and on. Caesar is most capturing forcefully, typically collecting and preserving the evidence. Go to the crime scene, walk through, identify the evidence, collect the evidence, and preserve the evidence, right? I'll give you an example. If you're seizing a mobile device from a crime scene, the data in the mobile should not be modified, right? So we have something like a specialized bag called Faraday bag. You put the mobile inside that, zip it, lock it. After that, you make a call to the mobile, it's say unreachable. Because the Faraday bag does not allow any communication in and out. So those sort of specialist packing devices are there. So there are like, even when we attended the Interpol meeting, Interpol has a guideline saying that Interpol guidelines for digital forensic investigation, Interpol guideline for first responder. That will clearly give you a picture. What are the standards? What are the publicly available tools, techniques, hardware, softwares that can be used? So Caesar, go to the crime scene and get the evidence. That is called Caesar. Acquisition is typically acquiring from the evidences. So what we do after seizing the evidence, we use a write blocker to make sure the data is not overwritten or any bits and bytes are not added. After doing a write blocker, use image the evidence and hash it. So after write blocking and hashing, what we do, we authenticate the evidence. This is a verified evidence. After authenticating, you acquire, acquisition, one, you take the control. So you make 1 copy, 2 copy, 3 copy of the evidence. That is called creating duplicate or cloned evidence copies. So that's what in technical term we call it as image or imaging, or we call it as a forensic image. Analysis. This comes the part of the, here comes the part of the forensic tools. You say open source tool, you say a free proprietary tool, the tool will start something on this analysis space. There are tools for acquisition, analyzing, imaging also, but actual forensic investigation starts in this analysis space. You have a hard disk, image it, hash it, send it to a forensic lab in Hyderabad. So they'll verify the chain of custody. They'll read what are the steps in which the evidence have passed through. They'll validate the MD5, SHA1, SHA2, any hashes. Then they start analyzing. If it's an iPhone, which tool to use? If it's a cloud data, which tool to use? If it's a normal hard disk, which tool to use? If the mobile is locked, how to unlock and take it? So that's all about the analysis phase. Making a report, documenting the chain of custody, step-by-step activities done by the forensic investigator and team. Preservation, a disposal of backups. Yeah, how many copies are advisable? Okay, there's a question in the chat box. How many copies are advisable at minimum? As I've already said in the earlier sessions, 3 copies are recommended. You have an original hard disk. The first copy should be kept with the hard disk, packed and kept it in a safe. You say police evidence safe. So the same thing will be produced in the court of law. So the first original evidence with the first copy, because you need to verify it, right? After 6 months, 3 months, even after a year, you need to verify that. So the original copy with the first original evidence with the first copy will be locked, packed and kept it. Second copy, as I said, it need to be given, if there's a protocol, it need to be given to the opponent, whom we are suing the case, opponent lawyer or opponent team. They have a right to ask for the copy of the evidence. The third copy will be investigator copy. We can make multiple copies from the third copy. So bare minimal recommended is 2 or 3 as per the protocol. Right? I hope I answered the query. Now, so preservation is something called as disposal of backups. This is a quite interesting scenario. So still I remembered a case in which we raided a bank, raided in the sense we just had proper authorization for investigating a bank. We did all the things and we know who committed the thing, which employee committed the crime, and everything is done. But at the end of the day, the investigator has 20, 30 hard disks from the bank, copies of hard disk. You know, like what will be there in bank systems? Sensitive information. It can just bring down the stock of some banks, right? So how to dispose it? So if I'm taking 50 copies of the evidence as hard disk, I say, hey, I've disposed it. Being a forensic investigator, I do format. Being a forensic investigator, we clearly know how to recover data from a formatted hard disk. Then how to dispose the backup, typically copy of the evidences. You see in real world, we have something called as a shredding machine, shredder, paper shredder. You put the paper shredder inside, it will cut the paper into small pieces. Same way, electronic shredding machines are available in which you put the hard disk, it will cut the hard disk into small bits and pieces. There's not any possibility for recovering the data. So this is similar to you see in movies, right? Let's say, let me give you an example. Hanged to death. An individual have been given a hanged to death. What they'll do, they'll wake him up in the early morning, 4 or 5. Doctor will examine him. Then they'll hang him, keep for 30 minutes. They'll bring down the body. The medical examiner, a government doctor will certify. Then the superintendent of the police will sign. Then it will be sent to court saying that this person is confirmed dead or died. We hanged them, right? Same way for disposal of backup or evidences. We can't randomly say that, hey, I deleted the hard disk, I formatted the hard disk. Now we don't do it in real time, right? So in this scenario also, we will have an affidavit. If you're disposing a backup, obviously you need to have a photograph recommended for a videograph in which how you dispose the backup. That have to be videographed. The video has to be hashed. Hash should be written in a CD or DVD and given in the court of law. And this is a general procedure of disposing the backup of the evidences we have. But in real time, this is not done in all the cases. Only very high profile sensitive cases, this disposal of backups has been done. After the case is solved, judgment is given in the court of law. Final thing is going to be on the reporting. Document all the above process done on the evidence to prove it in the court. You make a forensic report. There are many reporting formats available, open source formats and proprietary formats. At the end of the day, you have 5 hard disks things. I'll show you a report like taken from one of the vendor called Mobility. So a report which is taken from a mobile device, is taken Android mobile, will be like 15,000 pages. You might have not seen a PDF in the size of 1 GB, 2 GB PDF file, right? So that's big, the size of the report or evidence will be there, because it will clearly say past 5 years, the mobile day when you got the mobile till today, what all the calls you made, what all the photos you had, what you deleted, everything will be there. So mostly forensic report will be so extensive. So that's what we have a scope of the case. What is the scope of this case? I need to say using this mobile, last week he mailed. So mobile, date and mail. So you need to gather only the limited evidence. Right? You need to produce the whole evidence, but you need to make a consolidated report of the limited evidence. Final thing is presentation. There are some minimum qualifications to become an expert witness in the court of law. You need to be certified, you need to have professional experience, you might have handled some cases, just like getting a BTech, MTech, PhD, you have some qualification. There are some not written, not hard-coded expert witness qualification, but there are some qualifications available which can be proven, saying that, hey, I am an expert witness, coming into the court and saying that I am a CHFI certified, I am into academics for 10 years, I am teaching for this, I have already handled some 50, 100 cases. So you can go to court and be an expert witness, explaining the court or jury, saying that how you did the analysis. Right? So these are the general steps in digital forensics. Now I'll quickly walk you through the tools and techniques. Fine. I'll show you the tools anyway. I'll just share you a copy of this, right? So tools whichever I'm naming here, listing here, are the most commonly and publicly used tools in digital forensic. Autopsy. Fine. Autopsy is the most publicly available open source, the so-called free, completely free tool for doing a digital forensic investigation. Starting from imaging, acquisition, recovering, analysis, reporting, everything can be consolidated, done in a single tool called autopsy. The sleuthkit is the command liner tool. Autopsy is a graphic mode tool. Next, finish. Sleuthkit is a command liner tool. In the black window, you need to type imaging, hashing, and everything. Fine. So 2 versions of this tool. It's available in autopsy website, autopsy.org. Fine. So you'll be able to find the 2 versions of this tool. So with respect to academics, whichever courses I am handling for my students, master graduates, bachelors, and even BSc, MSc courses, when you just teach them something on forensic, you give them a hands-on, it starts with the autopsy tool. All-in-one tool for doing a open source digital forensic. Then this tool is called as bulk extractor. As the name goes, you give a hard disk, you want to extract only the email. You want to extract only the photos. You want to extract only the Excel sheets. This will do it for you. You give any big evidence, you can see. You can put an image file as an input, image in the sense forensic image. You can put a raw device as an input. You can give a directory, desktop, C:, D:, everything. So you can select it on the right side. I want the email. I want the zip file. I want the PDF file. You can select it. After it will take some time depending upon the size of your evidence. It will extract and give it to you. Bulk extractor is yet another tool for extracting evidences based upon the file type. Volatility, publicly available tool for memory forensic. We talked about RAM, right? So in real world, we use this for malware analysis, identifying a malware. This is typically showing you a C Windows System 32 process. So where this malware comes from? What is the malware process? How to isolate the malware? How to report it? Fine. All these things comes with a framework called volatility. It's a Python-based framework. Vol.py space infected vmem. They have taken a memory file, the DLL file, process number 1824. They are analyzing a single process that may be a virus process. Oxygen forensic, the most common and publicly available paid version of the commercial tool, Oxygen. We call it as Oxygen forensic for mobile. See, older days and even nowadays, Skype chats are encrypted, right? So, but this tool is able to just do some side channel and it's able to give you what is a Skype chat. Who did the Skype chat from this iPhone? Simon did a Skype chat with Larson. So Lars, and how many calls he made, how many chats he made, everything is made. So you give you the mobile, it analyzes whole mobile and give it to you. It's a commercial paid tool. Even you might not get a commercial trial of this tool. It's completely paid tool. You need to pay and get the tool. Mandiant Redline. Now it is called FireEye Redline. Previously it was Mandiant. Redline is a tool for commercial memory forensic. Volatility is a free memory forensic. Redline is a commercial tool for memory forensic. Bit of guy mode will be there. You can see here. This was a command liner and this is a graphic mode. Then Ncase, we saw autopsy, right? Completely open source version. Ncase is a commercial paid version that is have an advantage of proving in court of law. So we make an evidence, make it using Ncase, make a report in Ncase that can speak in the court of law. Commercial version of all-in-one forensic tool. And we talk about operating system. We know, right? Windows, Kali, Backtrack, different OS. Kane is one of the OS. So it should have inbuilt. You see what is there in Kane? Autopsy, Guy Major, hashing tool, photo recovery tool, disk checking tool, mounting tool, all forensic tool. When you click on the start in your Windows, it will show you MS Paint, calculator, something like that. This is a forensic OS, so it has all forensic tools inbuilt. Okay. And this is a forensic workstation. So there are quite a good number of workstations. This is Celebrate, one of the vendor. See what they are doing in the crime scene. They are taking it to the crime scene. See Samsung mobile using the tool. It will have a write blocker inbuilt. It will have a hash checker inbuilt. And they are copying it to the removable hard disk. Fine. Explico is an open source NFAT tool, network forensic analysis tool. So you can capture the network of your company organization for 1 day, 2 days, and give the network files here. Mostly it will be pcap.pcap. You give the file. Yesterday, it will clearly say afternoon 12 o'clock, a virus came into your system. But all you already had captured your network packets. Then this is the most commonly so-called hackers OS, Kali Linux. Kali Linux has a forensic, different types of forensic tools, carving, hashing, imaging. Then DFIR, SANS is a global body, global group, just like we call IEEE society. SANS is a society which is working on real-world digital forensic. Now we are talking about hard disk cloud forensic. They might be working on metaverse and different dimension of forensic. They are the leaders in forensic. So they released their own OS called SANS DFIR, Digital Forensic and Incident Response. I hope this is free, completely free from SANS. Then hex editor. You remember we saw this in file carving, right? X-ray tool. Any data you give, it will just show it in bits and bytes, hexadecimal equivalents. Then digital forensic framework, DFF, one of the most publicly available framework, just like Autopsy. I hope this was closed in 2017, but still available in GitHub. Then Kali is the hacker OS. In forensic OS is called Parrot. You can see the Parrot icon. So this is a Parrot OS which has all forensic tool installed, inbuilt. So if you want to start teaching students digital forensic, I recommend you to start with Parrot OS because it has all tools inbuilt. You don't want to go and install anything separately. DEFT is another forensic OS, and on and on. So if you talk about open source tool, Autopsy, FTK Imager, SIFT, Volatility, Bulk Extractor, different OSs are free tools or open source tools. And we have something on the paid or the proprietary tools. Encase, Paraben, Oxygen, Helix, Celebrite, Mandiant, many. I've listed only very few. And finally, when we talk about R&D, sir, from the first we are talking about hashing, imaging. I don't know how to image an evidence. I don't know how to image a pen drive or a hard disk. Give me some samples. Give me some sample evidences, right? So if you are in that verge, so there are 3 websites, 3 groups from NIST, NIST standard body. NIST has CFTT, Computer Forensic Tools and Testing. We can verify the forensic tool. NIST has CFREDS, Computer Forensic Reference Data Set. Fine. If you want, I'll show you NIST CFREDS. My screen is visible, no, sir? Like the Google search?
Yes, sir, it's visible, sir. Please go ahead.
So this NIST has a portal called CFREDS. There is Computer Forensic Reference Data Sets. So that will have a list of evidences. I want evidence of a hard disk. It will be there. I want evidence of a sample pen drive. It will be there. So if you want, I'm searching for something on metadata. But that's my research area in which. Let me browse the data set. In this, recently when I did my research, right, I uploaded my data sets, see Ashok Kumar Mohan's metadata data sets. So this is a research work which I have done. I have uploaded my metadata data sets in which how metadata changes when you just copy the data from mobile to cloud, cloud to mobile, Facebook to WhatsApp, WhatsApp to on and on. So this is my standard data sets, which I've already uploaded into NIST data sets. I've contributed to this community. And you find quite a good number of data sets. When you just go back to their official portal, you can search. If I want an example of an image, it will give you 10,000 sample image data sets, right? So if you want a hash image of a media sample, 8 pictures, wireless data set, email data set, sample data sets, quite a good number of pen drive sample data sets. Many things will be available. So this CFREDS, Computer Forensic Reference Data Set, it's official NIST. For all, most of you are faculties, academicians. If you're writing a paper, if you're talking about data set in forensic, any data set from the NIST CFREDS are approved. Because we cannot take some random files from our mobile and claim it to be a data set. Research community reviewers won't accept it. So any data set from here will be authentic. We can verify it here. Yeah. Then NSLR, typically National Software Reference Library. Some sample, say they have US election data sets and other things that will be available here. Everything will be available in the NIST website. So this is going to be a bit of research part. So what next? Before we just get on to that, I'll just give you some bits and pieces at the end of this bit of part, theoretical and concept session. What we need to know if you want to be a forensic investigator. You're an academician, that's different. I'll show you a couple of books. We have a computer forensic, a book by Nielsen Philip. There is one book. And we have a computer forensic and cybercrime book by Margie and Briggs. Computer forensic by Cowan, that's what I regularly use. And we have some Indian author books also. So 3-4 books, I'll share you the references there. But if you want to do a real world forensic investigation, you want to be a part of investigation, supporting police people, or getting a career in cyber forensic, the mandatory prerequisites are these things which have been listed here. This is from my past 10-12 years of bits and pieces, mistakes I have done in learning forensics, right? We need to know web technologies, HTML, XML, suspect interviewing skills. When you go for real world, you know, like you have 100 people. You cannot take all 100 hard disk and analyze. So we will ask Sam 10 questions to all 100 people. Based upon their answers, we'll narrow down who can be a suspect. A list of suspects can be narrowed down. That comes in practice. Sound knowledge of relevant laws. At least if you are in India, we need to know about basics of Indian cyber laws, civil, criminal, and cyber laws. Practical knowledge of digital investigation. That's what you get when you work on to the paid or free tools. Thorough knowledge of the logs, servers, because not all data can be recovered at all times. Any forensic investigator is not going to solve all the cases. If you're not able to get the evidence, the next step will be finding the logs. We cannot say like the salary.document was there, but using the log, you can say like the file was there in the desktop. It was deleted. We cannot able to recover. You're not able to do a file carving. But some logs already says like the file was there. The older logs, different logs will be helping us to prove that the evidence was there. Not we are no more able to recover it, but it was there. Thorough understanding of ecosystem. You know what ecosystem, right? Ecosystem is the environment which we live in. GAFAM ecosystem. Google, GAFAM. Any guess? What is GAFAM? All these things we are using day in and day out. One is Google. G is Google. Can someone type what can be for AF, AM? A couple of A's, F and M. Hope everyone knows it, right? So we cannot deny it. Google is first for G. Second A, any guess? All company, can you name the companies? Amazon, sounds good. Okay, A is for Amazon, F is for Facebook, A is for Apple, and M is for Microsoft. Yeah. So we live in this ecosystem, GAFAM ecosystem. Yeah, sounds good. Google, Apple, Facebook, Amazon, and Microsoft. So we need to know how it works, right? We cannot investigate an iPhone without knowing what is the current Apple version or mobile version it's using. Then working knowledge of crypto and stego. Cryptography is password, breaking the passwords, knowing the passwords. Steganography is typically removing or identifying hidden information, typically sorting out hidden information. Stego, we call it as. Strong practical knowledge of password recovery tools. File system is interesting. We have not discussed on file system today. File system is typically Windows, Linux, Apple, Android. Each OS, each vendor will store their files in a different format. So that's called a file system. Windows uses NTFS, Linux uses EXT, Apple uses HFS, different file system. The way in which the files are stored and retrieved. So we need to have a thorough knowledge on file system. Whenever I make a course for academics, I used to keep 30% reserved for file systems. Because anyone learning forensics should know completely about file system. Updating the knowledge of latest cyber attacks that we need to keep in touch, new virus, new malware, what is coming in. Finally, the out-of-the-box thinking. We need to think like a hacker to identify a hacker or a crime that have been committed by the hacker. So these are some of the mandatory prerequisites, digital forensic investigations, based upon my thing, but not limited to, but these are some of the inferences. So with this, I'll stop the screen share. Fine, and I'll do one thing. I'll just, as I promised, I'll share you the syllabus. I'll show you one sample syllabus. Sir, till what time will be available? Now it is 8:50.
Till 9 o'clock, you can share your cyber
Sounds
forensic.
good, sir.
Yeah,
Okay,
and
so
9 to 9:30 question answer, sir. But if you want to extend, you can extend. No
no
issues.
problem, sir. Okay, and on a 10-15 minutes, I'll just shortly wind
Yeah,
down.
yeah, sure. Please go ahead, sir. So I hope all the respected faculty members and students, you are enjoying the sessions. You are getting more and more for the in-depth knowledge for the cyber forensics. So yeah, please go ahead, sir.
I hope my PDF is visible, right? Cyber forensic.
Visible, sir. Visible.
Yeah, sounds good. So this is a 1 credit code which I recently made for one of the institute in which I am the board of study member, right? So cyber forensic 1 credit course, obviously for 15 hours, we can make it as 3 credit, 5 credit for, 2 credit, 3 credit for 30 hours, 45 hours and 60 hours. This is a lightweight 1 credit course because nowadays government is encouraging to add 1 credit course, value-added programs to things. So we know the CO course outcome for this course, 5 chapters, knowing overall cybercrime and cyber frauds, how to identify a digital evidence, acquisition and analysis of digital evidence, admissibility and reporting of digital evidence. Last chapter will be on hands-on digital forensic. You can see here, overview of cybercrime and cyber forensic, classification of crime against individual property, nation, need for digital forensic, steps in digital forensic, scientific methods, incident handling. We have not talked about incident handling here. So incident handling with forensic triage. Triage is something we say like do a priority. You go for a place where something like unexpected happens, an accident happens. The ambulance will just go and analyze who's still starving for their life. They don't take the dead person. They don't take someone who's wounded on their finger or something. They'll take the person who can be saved now, right now, right? So that is they'll prioritize whom to take first and whom to take next. So in forensic, we call this called forensic triage. Triaging is you have evidence, but now the evidence in the RAM will change, but the evidence in the hard disk. So if you are going and analyzing, doing an imaging, you image the RAM first, then image the hard disk. So that is called forensic triage. Incident handling, you go to the crime scene. Incident is something abusive or unexpected, like so-called hack. So when something happened, we go for incident handling with forensic triage. That have to be sorted out. That have to be explained here. Then second chapter on identifying the evidence, Locat's principle, different types of artifacts, hidden data recovery, corrupt recovery, file formats, file carving, and on. Acquisition and analysis, write blockers, Caesar, bit streaming, hashing, chain of custody, evidence bags, standard operating procedures. We are not discussed on SOP here. SOP is standard operating procedure, which is followed. You know how to apply for a license, step 1, step 2, step 3, step 4. Same way, SOP will be for each and every action. How to do a mobile forensic, how to do a cloud forensic. SOP will be available. Standard operating procedures. Then admissibility and reporting, forensic lab requirements, how to set up a forensic lab, how to generate a forensically sound report, what are the basic cyber law parts. Then finally, hands-on digital forensic. I've listed mostly the open source tools because it's for academics. If at all you are going to set up a forensic lab on your institution with a paid tool or other things, that can be also integrated into this total 15 hours course. I recommend Brian Carrier's file system forensic book and T-Bridge's computer forensic book, because it covers the basic topics whichever has been listed here on internal, external, some sort of split up. So we can make it like because to do some justification for the topic which you have given, make your own digital forensic course. So we need to know the basics whichever you have seen here, and I have just covered only the bits and pieces, subheadings. So we talk about imaging. Bit by bit imaging will be there, streamline imaging will be there, remote imaging will be there, different types will be there, right? So if we get an idea of imaging, then we can just discuss on what can be added on to the syllabus or not, right? But whatever we have seen today on this is typically the mandatory prerequisites. So that is mandated for anyone who's just learning on forensics. We need to know this. Yeah. So just a minute. I'll do one thing, another 10 or 10 minutes. I'll just open a video and show it to you. So if I just show you a live demo of a tool, it will just eat up our time. So for our ease of use, I'm just showing you a video demo. Just a minute. I'll just stop the screen share. Yeah. Just a minute. I'll just share the other screen. So, yeah. So are you able to see my screen, sir? That's something on the VLC player.
Yes, sir. Your screen is visible.
That's good. So this video is available on the YouTube. So I'll share you the link shortly. Fine. So this is a forensic imaging which we did. That was during the blue whale case. The example, we just made a cooked case of the blue whale. Fine. See, USB write blocker. We didn't use the hardware write blocker. So we used a software write blocker, which can be installed as a software, which will act as a write blocker. So write blocker is enabled. But I'll just quickly walk it in. After enabling write blocker, we opened access data FTK imager. FTK imager is a tool. So we just creating an image E01 evidence file of a pen drive, the case number and everything we give. The tool will run for a while. Yeah. After that, we'll go to the folder. So in this folder, the image is done. 16 GB SD card of a Micromax mobile. This was way old, 2017, which we did this. So it will give you the E01, file name .E01. This can be opened only using a forensic software. You cannot open it with the MS Office or some other things. This Excel sheet is given as a summary document. It will show you what is the case, who's the investigator, what is the you see bytes per sector. Sector count 31209,472. These many sectors have been copied from the hard disk. Fine. So then when you scroll down, it will show you like what is the source data. It's a removable media. Yeah, true. MD5, SHA-1. You have taken 2 different hashes. See, in real world, someone will come and argue saying that this hash is not verified. This hash is broken. So we take multiple hashes, different hash algorithms to take hash on the same evidence. So this is on this. Then we open a tool called autopsy. Fine. Import, create a case, import the case, import the E01 evidence, open it. After importing the evidence, select all the parsers. It will automatically recover emails, photos, audios, videos. See, it have been taken. It will load for a while. Whichever is given on red color into mark is typically the file that has been deleted and recovered by this tool. Typically, the file has been deleted from the pen drive and it has been recovered. The 16 GB evidence. This case was something related to blue whale. So we see this. Yeah, this photo which you see on the screen. Fine. Sorry, I'll just move on to the photo. Yeah, and this photo which you see on the screen is typically a blue whale game in which that was a case in which the blue whale was used by a kid. The mobile was seized. In that mobile, there was a desktop icon called blue whale. So we need to know how the kid downloaded the tab, how the tab was used by the kid. Fine. So we are analyzed and there was a stego content here. So inside this photo, you see 2 versions of the photo. One version of the photo was small size. You see 23,700 bytes. Another version is 26,000. So we clearly understood like inside the second photo, something is there. So then what we did, we just went on to the analysis part. We just extracted the image onto the desktop. The photo was taken. We used a stego tool, steganography identification tool. After identifying inside the image, there was a secret URL embedded. URL means go.google.com. Typically a tiny URL to download the blue whale game. Right? So this was inside the pen drive that's been used by the kids. And you see, file system mismatch, salary.pdf. Everyone will open it and say, hey, PDF is not opening, file is corrupt. But this was actually a photo, BMP photo. So autopsy tool, this free tool has an advantage of identifying file mismatch. You create a Word document and rename it as a movie file and store it. Autopsy will easily identify. They do a MIME extension matching. So they can find the mismatched extension and give you an alert. Then, yeah. So that was recovered. They'll give you a timeline. See from 2010 to 2018, what all the content that have been available in the pen drive. How that have been deleted, recovered, how to identify. And finally, we can select which evidence. This evidence, see quick tag. So this is the evidence in which I am tagging only this file. I don't want to tag all the photos inside this. Only these photos are evidences which I tag it to the blue whale case, and I just make the report. Once when the report is made, the final consolidated report will be HTML or XML or PDF report. That report will have who's the investigator, what all the 4 evidence files, how the investigation has been made, and all. So this is a short version of that things. I'll do one thing. I'll just these videos should be available in I'll post it in this also. So the same session which we had, right? Whole of the forensic session. First one has.
Hello, sir.
Yes, sir.
Yes, can we recover if anybody is actually deleting our log via they are actually doing any reverse engineering, reverse cell attack, or they are doing some behind the scenes some works, okay? And if
Okay,
any log is generated and they are actually deleting that log, can we recover via this autopsy?
Okay, so if you're talking, what exactly the evidence that have been deleted, sir? What was the crime scene?
Actually, might be they are accessing our PC via the
Okay.
remote access, and any
Okay.
of the log is generating
Okay.
for remote access of that particular PC. So any log is generated, and if any log is generated, then if they are actually deleting that log, how we
Okay.
can recover that logs?
Fine, sir. So if you're talking about, for example, someone have committed an offense, they have put a virus in your system, and they are deleting the logs of, let's say they are deleting the logs of your Windows Defender. Fine. So logs are going to be heterogeneous. Currently, we are having SIM SOR sort of solutions in which so you won't be able to recover the log, but we can also prove saying that this log has been deleted or modified. So let's say like a Defender log has been deleted or modified. That time, if you have another log of another third-party application, maybe another antivirus solution or some other softwares, so that can be sorted out. So maybe a solution whichever you're asking for this. So we need to go for integrated solution called SIM or SOR, SIEM. You would have heard of the integrated solution in which it will collect logs from all different heterogeneous location and consolidate it. So individual can delete. If you take Windows, we know Windows event viewer, we know Windows Defender, 2-3 logs we know. They cannot delete the logs from all the sources. Ultimately, they need to format the system. If that is not done, so we have a SIM SOR solutions for identifying that.
Thank you, sir.
Yeah, thank you. So just a minute to conclude the PPT. Just a yeah, I'm going back to my slides. So let me conclude it before we start with the questionnaire session. So what we see here is like bird's eye view of digital forensic. You don't know what the eagle is looking at, right? It might be looking at its prey. So today we saw something on file carving, mobile forensic, browser forensic, metadata forensic, cloud forensic, browser related artifacts, star, and different areas are there. So we got an introduction to digital forensics today. So whichever area we want to analyze, investigate, do a research, it's up to individuals to do. So yeah. So this is about me. You can just go Google for my name. I'll be available in akmohan.in. Generally, I'll be available in most of the social medias because that's how I started doing forensic, doing research on all social media accounts and on. So now we are open for a questionnaire session.
Yes, thank you so much, Ashok sir.
Yes, sir.
We had a good sessions from you about the digital forensics. So floor is open for you students and respected faculty members. You can ask questions about the digital forensics, what you want to know.
Yeah. So there was a question in the chat box. Sir, can we take evidence from the live OS, which are running only on RAM, even after PC is completely powered off while the restart? That's all. Okay. So if you're talking about running a bootable OS, let's say you're running a tail OS or something like Tails or similar variant, right? So if you have access to that system, you will be able to run, because when we talk about a live OS, the live OS, if you might have rebooted the system, you don't boot on the hard disk, you run something on the RAM, right? So you need to have a compatible adapter. If someone is running a Tails OS live in the system, you get them red-handed. you don't allow them to turn off the system. The pen drive is still intact. It is connected to the computer. Hard disk is not booted. The pen drive is active. Then you have some of the commercial forensic tools, which is capable of taking a copy of the current instances of the running device. Right? That's possible, but like there are quite a good number of challenges in proving them in the court of law because it's a live OS. We don't have much of benchmarks on the basic hash and other things, but that's possible. It can be done. Yeah. So any other questions, queries regarding forensic?
Yeah,
Yeah,
participants.
obvious. So whenever we talk about this keyword comes in things. Finding needle in the haystack. You have a bigger haystack and you want to find a needle. So that's common. But this is like a general saying that it's hard to find a needle in the haystack. But being a forensic investigator, we'll have an optimistic approach, right? So we'll say like I have thousands of evidences, bits and pieces. If I get 1 or 2 bits pieces, I'll connect the other 2 pieces. So that's what we do in the evidence. As we're talking about log, right? File is deleted, the log is there. This clearly says this log has been tampered, this file has been deleted. It's typically an instance, just proving that the opponent is guilty. Prove them guilty in the court of law. The rest is upon the arguments, right? We might not be able to recover the whole of the digital evidences. Finding bits and pieces, connecting them, proving the opponent guilty, that is more than enough. It's a half success for a forensic investigator in that case. Yeah. Which OS is better for practical like Kali, Parrot? My recommendations will be Parrot if you are doing a forensic investigation. If you do it with mixture of pen testing or hacking, Kali is good. Parrot is recommended for forensic related investigation. There are hundreds of variants. I used to take different courses for different countries and all. So each variant, they'll ask different variants. Suri is one and many things will be there. So, but recommended if you want to on the general search, Parrot is recommended for learning forensics. Yeah.
How about Kane, sir?
Yes, sir. Kane we have deft, we have sans DFIR, we have whatever I've shown in the list, right? Everything is available. Kane and other things will be lightweight. If you want to learn newly, right? So we'll start with the Kane OS because the Kane is having only limited tools. Kane will have like 10-15 tools, but Parrot will have a consolidated list of tools. So anything, for example, it's not like that Parrot is so superior, Kane and deft and other things are normal. See, whichever you feel you'll start, you can start with the things because all are going to be having the same open source tools. 90% is going to be the same. Only 10% there'll be a slight difference in the tools and updates of the recent version of the tools.
Sir, open source tools, when we are doing a forensic investigation, is admittable in a court, and only we need to have a premium software for the investigation.
Okay, it's not mandatory to tag it as a premium software. So because open source software, when you talk about, even when you talk about the open source version of Linux or anything, right? The question comes in like this is not having a standard procedure, right? Anyone in the open source research community can contribute it. They can edit the kernel, they can edit the layout, they can edit anything. So that's what in court of law, they don't accept open source. That is commonly applicable for our forensic tools also. But in some courts, like they used to accept whether you've just taken using this autopsy or any other tool, they'll give some consideration to plead the opponent guilty. If you're giving some evidences, that will be accepted. It won't be accepted as actual evidence. To plead them guilty, that will be taken as an additional point advantage. But you need to, because commercial tools, right? You name any commercial tool, the commercial tool will have a standard. They'll regularly release the updates. They regularly stick on to NIST standards, compliance of policies and all. So obviously there is very less question on the commercial or proprietary tools.
Thank you, sir.
Yes.
Sir, for the malware or ransomware forensics, in case the PC was encrypted through the ransomware, in that case again we are taking a backup, right, sir?
Yes, sir.
Is it? I mean, encrypted PCs backup? Is it possible, sir?
Backup is possible, sir. For example, let's say your hard disk is encrypted by a locky ransomware, right? So you can take the backup of the hard disk, forensically sound backup, but that's not going to be of any use because the whole data is locked and kept inside, right? So even older days, we know ransomwares, maybe first versions, even when I was handling the first few versions of the ransomwares, they'll encrypt and keep the key inside the OS itself. So we go and hunt for somewhere on the registry or somewhere on the temporary files, it will be fine. Now what they are doing like bit level encryption. Each and every file they are using different keys to encrypt. Right?
Yes, sir.
So that is pretty hard nowadays to just sort out. For doing a forensic imaging of an encrypted hard disk or evidence is possible, but that's going to be only as a yet another copy of the hard disk and completely encrypted AES RSA 128,024 encrypted hard disk.
But but it is very difficult to reach to the attacker, right? In the case of the ransomware.
Yeah, obvious. When whomever is just doing a ransomware related, they used to give you some different random mail IDs that are going to be anonymous. They'll give you crypto wallets, completely anonymous. So, and there is going to be only one key that's going to unlock your evidence. So most of the scenarios, even many high profile cases, worst case, the try you say 90%, they used to pay it and get it back. Next time they'll take some precautionary actions, being not getting infected. But that's most common. That's what the ransomware industry is surviving nowadays.
Okay, sir. Thank you.
But there are some research, sir. Kaspersky has something called as no ransom. So
Yes.
whichever is available, not so recent, 6 months, 1 year old ransomware versions, they have the decryptor keys available there. And even if you want to do some additional research, you can go on to dark web, deep web. There are some forums in which you just get the decryptor keys of some ransomwares, but at your own risk. We know how dark web and deep web are there.
Right, sir.
Yes.
Okay, noted. Yes, participants, any more questions from your end? Sir, one more question from my end.
Yes, sir.
Can you put some lights on the IoT forensics?
Okay, sir. When we talk about this IoT forensics, right? So there is not any standard, typically procedures, standards for IoT forensics. We'll stick on to IoT OWASP top 10. Currently, OWASP released in 2018, I think so. So OWASP top 10 is available for IoT forensics. And when we talk about individual IoT forensics, it's typically purely based upon the environment. If you're talking about a SCADA system, if you're talking about a real-time system, if you're talking about something on, we have seen some miniature versions of IoTs. We have been monitoring some attacks on some fishery units in which the IoT network has been compromised. So it's all about the scope, sir. So, but if you, as a benchmark, you can start with the OWASP top 10, sir. OWASP top 10 for IoT.
Right. Okay. OS top 10 for the IoT.
Yeah.
And the same process, the same steps we can follow for the IoT forensics, right? Like identification.
OWASP have exclusively released top 10 for IoT.
Oh,
so not on the
okay.
web application top 10. If you Google for OWASP IoT top 10, just a minute. Let me open.
Right.
OWASP IoT top 10, they have it. So I hope my screen is visible, sir.
Yes, sir. Your screen is visible.
So they have, if I'm not wrong, it was released in 2018. So now they have the current, maybe updated versions also.
2021 will be there, I guess.
Yeah, you can see here. This was in 2018.
Yeah. Okay,
Yes,
for the Internet of Things, separate OS top 10.
Yeah, separate thing is there. It might be a bit of overlapping with the existing things. But this is most common: guessable packet, weak password, hard-coded, outdated components, firmware update, something is happening there. So this will cover more than 70-80%, excluding the APT's new versions of 0 days and down.
Right, sir. Okay. Noted. Wow, great. Okay. Any more questions from the participants, respected faculty members and students? I'll give you 2 more minutes, then we will wind up the session by summarizing the today's sessions. Yes, anybody? Yes. Please rate today's sessions out of 5. 1 is poor, 5 is best. In chat box, you can write.
Yeah, there is a question. Every OS keeps log for deleted. Yes, sir, every OS have log for deleted or created files, but the logs of that also be short-lived. Let's say like it have a log for last 30 days or 90 days, right? Paid tools available to everyone because we are being an academicians, right? So with respect to my experience, you take 10 paid tools, 7 of the paid tools are giving academic license. So if they're giving it like a 30-day trial, 60-day trial, or even 1 year license, we are getting. That's a tool called Multigo we use for forensic. So academic license for Multigo is available for 1 complete year. We are using in our university. Wherever I'm entering, I'm just using it there. So 7 out of 10 paid tools have their CSR, and then they just give free at least a complete feature free for academics. So you can apply from your academic ID and give a try. If you want a consolidated list, I'll share it with Snehal sir, or you can get in touch with me. We'll just work it on. Because we are also supporting, we have some startups in which we are also supporting colleges, organizations to set up forensic labs for academic purpose, for research purpose, or no.
Yes, yes, of course, sir.
Sir, can you give any idea how to take a benefit of other forensic department into the digital forensic department? So if they are doing graduation from the other forensic department,
Yeah.
now we want to take a benefit or get a leverage of that forensic department into the digital forensic department. Any idea for this project?
Okay, sir. So if you're talking on general forensics, right? Maybe ballistic based or chemistry based or something on general things, right?
Yes, perfect.
Yeah. So even I have some of my friends, those who have been instructors, professors in other forensic departments. But when we get some time and we sit and discuss on this, right? So these two are parallel roads running entirely on a different track. You see, we take a track, right? Both will be running parallel. We'll see side by side, but we rarely overlap onto that. But if my recommendation from other forensic department, if you are getting on to digital forensic, we need to follow this general procedure. So as I said, right, we can take a course. There are n number of MOOC courses available on YouTube. So if you're talking about any certifications, like there are some, the most commonly used like CHFI, EC Council.
Yes,
I'm an instructor for this, right? So EC Council, the most fascinating certificates available on the market. They give something on computer hacking and forensic investigator V10. So I'm an instructor for that. Previously it was V9. V10 is quite interesting. They have some additional tools that have been added. Because you go out in the market and say like, hey, I know digital forensic. So they expect some sort of recognition. So not only these things you see like CDFE, CNFE, Mile2, that's a vendor on this, who's giving digital forensic course and network forensic course with completely recorded videos in which we used to offer it here. Many things are there, sir. So if you are from a cross major, recommended if you go to YouTube, search for digital forensic MOOC series, MOOC. It will give you 8 hours of video, complete video, whichever you have seen with tools, demos, step-by-step live demo, it will be there. So if you are from cross major, it's not saying that you won't be able to get into digital forensic, but there will be very few overlaps of your traditional forensic and this.
Right,
Yes,
sir. Okay. Any more questions?
Yeah, how IoT forensic works. As I said, like IoT forensic, typically doing a forensic on IoT environment, we don't have any global standard. Even we don't have any local standards here with small vendors or companies. So purely based upon the forensic is typically, when we talk about forensics, is doing a post-mortem analysis. Something happened, we go to the crime scene, we take the evidence and analyze it. So depending upon the scope, we define. If it's an IoT environment in which all cameras are involved, CCTV cameras are involved, let's say a Mirai variant of botnet have infected it. So we define the scope, we define the infrastructure, what all the evidence is. It's the cameras, what all the chips available, what all the memories available. Just like we do imaging on a normal device, we try to do an imaging on the portable devices or the lightweight or IoT devices. It goes on. So defining a scope on IoT is much more cautious when we just go for a forensic, because if we go for an IoT environment, we tend to do forensic day in and day out. The devices will be populating on and on. Yes.
Yes. Wow, great session from the Ashok Kumar Mohan sir. Thank you so much, sir, for such a wonderful session. We learned a lot from these sessions related to digital forensics. So let me summarize these sessions. We started with some keywords, jargons, and definitions of the digital forensics. Sir has started with the definitions of the digital forensics with the good examples. Sir gave the examples of the Locard's exchange principle. Then we gone through with the different stages of the digital forensics, like identifications, preservations, collections, processing, review, analysis, productions, and presentations. Sir has nicely explained the different keywords like file carving, disk image, write blocker, hashing. So there are number of keywords. This is not limited, right? So sir has nicely explained the chain of custody, which is very important thing. Sir has nicely explained the metadata also, stack versus space, and we discussed about the tools and techniques. Some tools we have gone through, which are the free versions, open source tools, and some tools we discussed about, which are the paid versions. We discussed like autopsy, bulk extractor, volatility, oxygen forensics, mobile tools, NCAS. So number of tools we have discussed, right? So this is really we discussed about the NIST standard also, and that was a really wonderful session and very fruitful session for us, a very informative session for us. I really thank you so much from the RK University School of Engineering, Rajkot, and from the on behalf of our director sir, HOD sirs from the RK University, and participants and the faculty members who are the participants in the faculty development program. We heartily thank to you, sir. Thank you so much, sir. Any message from you, sir? From your
My
end?
concluding note is I already put in the chat box, sir. It's all about
Yeah.
sharing, right?
Yes.
Maybe whatever
That
I've
is-
learned last 10, 12 years, I've just added it here. So sharing
Yes.
security, happy sharing, be in touch.
Yeah, sure, sir. Actually, we need to decode this one, right?
It should be, this is how password should look like, sir. We don't keep our
Yes.
mobile numbers or password, easily crackable.
Right, sir. Right, sir. So,
Yeah.
I request participants, if any suggestions, feedback for these sessions, or any questions, you can put in the chat box. We'll definitely get back to you. So, with these remarks, let's wind up the second online session from the ATAL FDP hosted at the RK University, Rajkot. Again, thank you so much, sir.
Thank you all. Have a great day.
Thank you,
Bye.
sir. Yeah. Take care, sir.
Yeah.
Bye bye.
Take care, sir.
Yeah. Okay, participants, signing off from the meeting. You can put any suggestions or feedback here itself so that we can get the idea how our things are going on.